Hi, everyone, and welcome to our session with the buzzword-filled title of Agent-Driven MCP on AI Workloads for Kubernetes. I'm Ganeshkumar. I'm a software engineer in the Azure Kubernetes Service team at Microsoft. I primarily work on GPU infrastructure and making it easy to run GPU workloads on Kubernetes. I've developed projects like the GPU node problem detector, fully managed GPU experience, and also made it easier to use the latest GPU VM instance types on Azure. I've virtually seen every single GPU-related issue or incident in AKS over the last few years, and so I have a lot of a deep relationship with different AI infra issues. My co-presenter today is Qinghui, who also works in the same Azure Kubernetes Service org. He primarily works on Kubernetes for AI and making it easy to deploy, fine-tune inference and deploy inference workload and fine-tune other models as well. And he is a lead maintainer for the Kubernetes AI Toolchain Operator, which is a CNCF sandbox project, and he's worked in the infra space quite extensively. He's not able to make it today because of some travel complications, but his recording is there, which I will show later in the presentation. This talk was motivated by a couple of experiences that I had over the last year. So about a year ago, during a hackathon project, we wanted to deploy Llama 3 405V model in a Kubernetes cluster. And in that process, we had so many questions. Things like, how much memory do we need? Which GPU should we pick? Which ones do we have quota for? And other questions around how these choices would impact latency and throughput downstream. So we were essentially overwhelmed by these questions. And for someone who's new, these questions would also need to be answered for every new model that they deploy. And so I was wondering, how can we use an AI agent to take these AI infra actions and choices autonomously and optimally? Then, a few months ago, there was a production incident related to GPUs and one particular series of GPUs, where the GPU node would get provisioned, the pod would run successfully as well, and it would be able to use the GPU workload. But 20 minutes later, the GPU performance would get degraded, and a day later, it was virtually unusable. What was also noted was that it seemed to happen after a node image upgrade and also after new driver versions were present in that node image. So we knew it was something to do with the drivers or some configuration. And this had very bad timing where a major user had a very important conference where they wanted to present a live demo and launch this product, and their clusters were getting impacted because of this. And at that time, I was wondering how things would be if the end user actually had an SRE agent running on their cluster that would be able to prevent bigger impacts and issues, and also a code fix agent on the product side. So the SRE agent could detect the issues quickly and proactively, perform some mitigation actions, such as rolling back or applying any temporary fix that would fix the issue, and then verifying that the mitigation actually worked. And from the product side, I would have found it quite helpful to have an agent that gets signals from the incident, is able to root cause the issue, and also make the fix, make the PR for the fix, add tests, verify it, and roll it out. But what I realized was none of the agentic workflows that we had there would be able to do this completely and fully end-to-end. So the North Star of this vision is to have infrastructure that is fully managed by AI agents. And by fully managing, I mean all the different aspects that we talk about, from configuration management to deployment, remediation, and also doing ongoing monitoring telemetry as well. And my prediction is that AI agents will be primarily managing our infrastructure in the next few years. I think it will be probably 5 years or so because of the rapid pace of model development and improvements in agentic workflows. But I would also be curious to hear about your experiences with AI agents and your thoughts on this. So we've got a few just 3 poll questions, and I would love it if you're able to scan the QR code there and answer these questions. And I think it would be useful for the audience to know where everyone is as well. Yeah. So that QR code, or you can go to the URL on top. First one is, have you used an AI coding agent? So this could be anything from a VS Code coding agent to Cloud Code or OpenAI's Codex models or Klein or something else. Okay. All right. So the majority of people have used an AI coding agent. That's great to see. Let me also show the next questions. One sec. OK, next question is, have you managed infrastructure with AI agents? And this is a sort of broad question, but it could be any aspect of it where you're actively using AI agents to manage infrastructure. OK, so most people, almost everybody hasn't used it. That's good to know. And yeah, this is a spicy question of how long you think it would take for AI agents to primarily manage our infrastructure. So I'm a bit of an optimist, so I've kept it from 1 year to 20 years. But I'm sure some people believe the answer is never, or 40 years or something. But if you believe that way, have it as 20. Yeah. OK, that's an interesting looking graph. Nice. So it's averaging around seven years or so, which means we know that KubeCon and other infra conferences will at least go on for 7 years. And after that, I don't know what agentic agents would have conferences for, but that's nice. OK. So in this talk, we'll go further and briefly define some agentic terms so we're all on the same page. Then we'll talk about what it takes to manage AI infrastructure. Talk about differences between AI for coding and AI for infrastructure, which, as we've seen from the audience poll, people are used to coding agents but not infra agents. Then go through a demo where we show how we could use AI agents for managing AI infrastructure, and then talk about what it would take to generalize this broadly and take this towards production readiness, and highlight also some new and interesting developments in this space. So for agentic terms, an agent is an AI-driven loop that just plans, decides, and acts. And tools you can think of as just like operations that you can call with typed inputs and outputs, and that could change your environment or other external environments as well. Context is simply just all the content that goes into doing inference for a model. So that's all the conversation history, any system prompts that the agent might have, then also other tool calls, tool definitions, and responses as well. And MCP is a protocol to discover just these tools and resources. So a quick example, we have, let's say, a prompt where you ask Cloud Code, which is the agent, if your PRs merged. So that goes into the context, and Cloud could make an MCP call to GitHub MCP to figure out whether your PR has been merged and send the response back and add it to the context. Going a little bit deeper into what MCP is an open source standard for connecting AI applications to external systems. And it's often compared to a USB-C port for AI applications, because just like a USB-C provides a standardized way to connect devices, MCP provides a standardized way to connect AI applications to external systems. So you could have an AI application like ChatGPT or Cloud Code connect to external data sources and tools like search engines or GitHub, or get the latest documentation, and also do other workflows. And this makes it significantly easy and interoperable for agents to talk to different tools. And that was a significant improvement compared to other approaches that were done before, where you had to manually make various combinations of tools with agents to support them. And if you're if you're new to MCP, you might be comparing it to the API, like REST APIs. And there are similarities, but there are some high-level differences. Essentially, MCP allows tool discovery and standardizes agentic behavior, and compared to just using API specs. But oftentimes, MCP servers actually call APIs in the background as well. So what does it take to manage AI infrastructure on Kubernetes? We start off usually with deciding what model to have, which flavor of model, whether it's a quantized model, which size of a model variant you want to pick, figure out how to package it. Is it going to be in a container image or in a different format? Then figure out the GPUs that you need, any inference runtimes, the operating systems. Also figure out how many users will be simultaneously running it in your cluster. Figure out scheduling. Also configure auto-scaling based on your requirements, and manage costs. As you know, AI infra is extremely expensive. And you need a lot of signals related to GPU metrics and general infrastructure observability as well. So for coding, we've seen agents which are able to use the information that's present in a repository quite well to make code changes. And usually these agents are, like the behavior for coding is more deterministic than for infrastructure, which makes it easier and safer to make coding changes because you're able to test with unit tests and so on. And there's a lot of training data available as well for coding agents, because there's lots of code on GitHub that is used for training these models. But for infrastructure, we typically only see partial information from different components, and it can be non-deterministic. There's so many flaky errors that you see due to network failures or something else which just get fixed later. So there's lots of noise. And blast radius for changes is quite large too, because you could bring down production, you could affect customers directly, and training data is quite sparse as well, because people are usually not uploading all of those infrastructure logs, or more importantly, the workflows that they're doing to debug. So the models don't have the knowledge to debug it completely. This is a very simplified view of the differences, but this would be useful to think about how we're going to build AI for infrastructure. And the other point that I want to say is, like, AI infra is actually just a subset of the problem of AI agents for infrastructure. So some of these techniques will apply for just AI for infra in general. So here's a high-level like architecture view of the demo that we're going to show, of one way to have AI agents manage AI infrastructure. So we go from a prompt, which could be something simple like deploy a particular flavor of llama models. And then it goes from the prompt to the agent will figure out where the model is present. If it's in HuggingFace, get the model metadata, make the MCP calls to the HuggingFace MCP. Then call other tools like the open source Kaito MCP, where you could estimate the model resource usage, how many GPU nodes are needed, and so on. And also call the corresponding cloud provider MCPs. Let's say you want to deploy it on Azure, you could use that MCP. And most cloud providers at this point are also having their own MCP servers that could be used. And once that's determined, it'll create the manifests, apply them, and then you can also verify whether it's working as expected. Now my co-speaker, Qinghui, will be sharing how that works through a demo.
Now it's my turn to introduce the demo using an agent to deploy an AI workload. As you can see, there are some MCP server there, the Kaito and HuggingFace and the cloud vendor, cloud vendor MCP. Now take a look at the system prompt. This system prompt was generated by the LLM, just to make sure the workflow will be stable. In this system prompt, we will define the workload to process this kind of task, including clarify requirements and how to generate the manifest step by step. It's all generated by the LLM. Okay, now launch the Cloud Code agent and try to let the agent help us deploy a Qinghui model service on Kubernetes and ref to our system prompt. Yeah, the first step, the agent will try to clarify the requirements from us, like the model name, quantization, cloud vendor, do you need auto-scaling, and the runtime preference. We just told the agent what we want. Yeah, after confirm from us, agent will try to process the requirement step by step. Regarding the region, just let the agent find an available region using the MCP. You can see it makes a mistake there. It's not Qing 2.5, it's Qing 3. It will clarify the model ID through the MCP, the HuggingFace MCP. Yeah, now you can see it will call HuggingFace MCP and search for the exact model ID from the server. Finally, it will find out the exact model ID from HuggingFace. It's Qing 3 8B. After that, it generates a to-do list to finish this task. So the next step is to query Azure to find out available GPU SKU with quota. And you can see we will search from the Azure documents to find out the available GPU. That's waiting. And after that, it will invoke the Kaito MCP. The Kaito MCP will try to estimate the model usage based on the model ID and a given GPU spec. And it will give the result about how many node counts are required and what's the model context length you can run. So the agent will measure this usage on this GPU SKU and give a suggestion, give a recommendation for the GPU. Now you can see there are 3 options: the A100 and the T4 GPU. T4 is a budget option. Then after that, it will try to generate the target Kubernetes deployment manifest. Just let it continue. For some steps, we will generate some code and a document based on our requirement. And you can also find out the cost, the estimated cost there. Okay, talk is cheap. Just let the agents do a real-world deployment for us. First, I will let you to create a fully managed GPU node pool and provide the resource group and the cluster name. It will help us create it. Just create it directly. The fully managed GPU node pool is a brand new feature. It's a preview feature released just last week. Let's see if the model can know about this new feature. Don't generate a script, just create it. It looks like the model cannot understand this. It doesn't know this new feature. So I will ask the model to search from the latest document, from the latest Azure document. Let's see what happens. You just search from the internet. Oh, that's cool. You find out the correct menu. The fully managed GPU feature is a feature that can automatically manage the NVIDIA GPU driver, the GPU device plugin, and the DCGM matrix exporter. It's all managed by the platform. Then, after a confirmation from us, the agent will directly create the fully managed GPU node pool. Oops, it made an issue saying the zoom constraints are too strict. Let's see what the agent will do. You may try another zoom. Before that, you need to delete the node pool just created because the name was confliction, the name confliction. So it will first delete the node pool and create a new one on another zone. Yeah. Okay, let's go. Let's do that. we need to waiting for the node pool to be ready. Yeah, so I skipped the operation here. Now you can see the GPU node pool was created successfully. And let's check if the GPU node is ready. It's all done by the agent automatically. We'll check if it's ready. I think we can check the resource, check the allocatable resource to see if the NVIDIA GPU resource. Let's see what the agent will do. Yeah, you can see the NVIDIA GPU available in the allocatable resource. Perfect. So the next step, I would like to let it just apply the generated manifest and deploy the deployment. So yeah, ask it to apply it. Apply the deployment and the surveys. We need to wait for a while. Just skip. And finally, yeah, the model server is running now. Then let's ask the agent to verify the LLM endpoints. Ask a simple question: when was the Atlanta Olympics held? And give me an answer from the newly deployed model surveys. That's cool. Atlanta Olympics was held in 1996. Cool. So the agent finished our task to deploy an AI workload on top of Kubernetes based on our requirement. Thank you.
Thank you, Qinghui. And as you saw, he went from a prompt to deploy a Quen model to the agent asking him clarifying questions, going through various steps, calling different external resources and MCPs, and being able to deploy it, handle errors, and make sure that it actually works in production. So you might wonder, can we do the same and add more MCP servers and just make it completely work in production for just a generalized infra agent? So many different MCP providers exist today. So can we just chain it together? The answer at high level is currently it's quite difficult to do that and make it work accurately. And I'll talk more about why in a bit. So to make all of this fully production ready and make sure that it's of high quality, we need to think about various different design aspects. And this talk is actually in the emerging track of KubeCon. So we wanted to share some of the newer ideas in the space and go through a high-level overview of these different aspects. So when you think of making production agents for AI infrastructure, you think of these aspects. A huge aspect is security. So thinking about how authentication and authorization work when you have an agent talking to multiple MCP servers, how do you pass in the information? What is the authorization level for each task that you do? There's also questions on how there could be prompt injection, perhaps, and the agent could expose secrets through if a user is providing malicious prompts. Then there's questions of how and where you run the agents and what type of agent sandboxes you can use to do that in an isolated manner. There's a huge other question of how you build guardrails and make sure that the changes are not causing issues and inadvertently. So an LLM should not do operations which are extremely risky on its own, or if it does, how can it do it in a safe manner is just an open question. And this topic of context engineering is also extremely critical because as context length increases, the performance degrades. So even if you have a fixed size context window, which is quite large, like 1 million tokens, the performance actually degrades when you use a large number of tokens, and especially if you have phrases which are lexically similar but not semantically similar. This technical report, which was recently released, talks about why that is the case. And in my view, that makes it complex for DevOps workloads where you have logs which are very similar to each other. So the LLM may not be good for in long contexts. Then there's also a very recent approach shared by Anthropic in a blog just last week, where they talk about how typical MCP workflows involve large context of large context because you have to load all the tool definitions. But with their approach, they actually are able to use code to do a lot of the processing outside of the model context window, and that reduces the context significantly. I would recommend reading the blog post, as we don't have enough time to go over the details here. And then there's a whole range of questions around how you could use multiple agents together potentially in the future. I think those are very new for now because we haven't gotten a single agent to work reliably at this time. And there are also questions on how you could use events to manage behavior. And memory management is also key. And there's some interesting open source projects on how you can even delete irrelevant context and so on, and how you can manage long-term memory. So the AI agents remind me of this clip from 60 Minutes from Rick Rubin. Let's see. Any chance you're able to play the sound? Hi. Could you please play the audio?
Know what I like and what I don't like. And I'm decisive about what I like and what I don't like.
So what are you being paid for?
The confidence that I have in my taste and my ability to express what I feel has proven helpful for artists.
I think AI agents today, especially for infrastructure and when you're calling multiple MCP servers, remind me of this clip because we're not rigorously benchmarking a lot of these agents and claims, and we're not making sure that it can work reliably and consistently. And what he's saying works well for artistic endeavors, but because we're engineers, we need to have these evaluations and performance benchmarks. And we have a lot of benchmarks for coding agents, but very few for complex distributed systems. So that is another major gap in this field, which would really push the field forward. So I want to summarize the key takeaways of this presentation. We started off by talking about what AI infrastructure involves, why you need expertise in many layers of the stack, how MCPs could be used, different MCP servers could be used as building blocks to configure the AI infrastructure. We showed a demo of using AI agents for AI infrastructure, talked about the architecture of it and how to extend it as well. Then we briefly touched upon different aspects of how you could eventually bring AI infra agents to production with high quality. I think this field is rapidly evolving, and things change every week. So I think this is a super exciting place to get involved in. And by this time next year, I expect the approaches to be shared to be very different from what I had shared before. Because as models keep evolving, context window increases, new techniques are developed as well for managing agents, we're going to have very different approaches in the future. So thank you, and hope you have a good time with agents.